Today, we're going to pull back the curtain on the secret sauce that makes the modern internet feel, well, instant. It's all about something called distributed caching, and it's the quiet hero that lets your favorite app serve millions of people without even breaking a sweat. Let's dive in.
You've totally felt this, right? You open one app and boom, it's snappy, responsive, everything's just there. Then you open another and you're just staring at that dreaded loading spinner. It's a universal feeling, and the answer, almost always, comes down to how that app deals with its data. And right here, this is the heart of the problem. For any app that has a ton of users, the database, think of it as the system's permanent long-term memory, is the slowest part. Every single time you refresh your feed or search for a product, that request has to go all the way to the main database. Now, imagine a million people doing that every minute. Yeah, the whole system just grinds to a halt. So, here's our roadmap. First, we're going to talk about why speed is such a tough nut to crack. Then, we'll introduce the hero of our story, the cache. We'll see how to take that idea and scale it across the globe, then dig into the critical rules that make or break a caching system. And finally, we'll look at how this all comes together in the apps you use every day. All right, let's kick things off with section 1, the need for speed. You see, as an app gets more popular, the challenge isn't just serving more people. It's about staying lightning fast for every single one of them. And that's where things get really, really tricky. This quote really hits the nail on the head. It perfectly captures the fundamental bargain of caching. To get that incredible speed, you might have to be okay with the data being a tiny bit out of date. It's a trade-off. You're giving up absolute freshness for a faster experience. And getting that balance right, that's everything. So if the database is the slowpoke, how do we get around it? Well, that brings us right to section 2, caching, the fast lane. This is the core solution that powers pretty much every single large-scale app you can think of. So what even is a cache? The easiest way to think about it is like a super fast short-term memory for your application. It's like a little cheat sheet that sits right next to the app, holding on to all the data that people ask for over and over again. This means the app doesn't have to make that slow trip to the main database every single time. And the way it works is actually pretty simple. When a request comes in, say you want to see your profile page, the app checks the cache first. If the data's there, that's called a cache hit, and it's sent back to you instantly. But if it's not there, a cache miss, then and only then does the app do the slow work of getting it from the database. And here's the magic part. It then saves a copy in the cache for the next time someone asks. Now, this is why it's such a game changer. The performance boost isn't just a little bit, it's absolutely massive. A read from a database takes milliseconds. A read from a cache, we're talking microseconds. That's 1,000 times faster. To put that in perspective, if a database lookup took a whole second, the cache lookup would take just 1/1000th of a second. That's the difference between an app that feels instant and one that feels totally broken. Okay, so a single cache is great. But what happens when your app is huge with users in New York, Tokyo, and Sydney? Having just one cache in, say, California isn't going to cut it for everyone. So let's move on to section 3 and talk about going global with caching. A single cache server can only do so much. It'll run out of memory, and if that one server goes down, your whole app suddenly gets slow again. That's a single point of failure. The solution? A distributed cache. Instead of one big server, you use a whole team of them working together. You spread the data across all these machines. This lets you scale up just by adding more servers, and it's fault tolerant, meaning if one machine fails, the others just pick up the slack. No big deal. But we still have another problem, the actual physical distance. The speed of light is a real thing. A request from Australia to the US still takes time. That's where our outermost layer of caching comes in, the CDN, or Content Delivery Network. This is basically a whole network of caches that are strategically placed all over the world in what we call edge locations. This way, a user in India gets their data from a server in Mumbai, not one all the way over in California. So what kind of stuff do you put in these global caches? Well, usually it's the heavy, unchanging content. High-resolution images, video files, the basic code that makes a website look the way it does. Sometimes they'll even store the answers to really common questions your app asks, all to make sure that data gets to you as fast as physically possible by being as close as possible. So we know we need a cache, and we know we need to spread it out. But how we manage the data inside those caches, that's where the real genius comes in. Welcome to Section 4, the cache's critical rules. These are the tough choices that separate a good system from a truly great one. Okay, the first big decision is how you handle writing new data.
With a write-through policy, every time you write something, it goes to the cache and the database at the same time. It's super safe and consistent, but a bit slower. Then you've got the speed daemon, write back. This just writes to the fast cache and immediately tells you all done, updating the slow database later on. It's incredibly fast, but it's risky. If that cache server crashes before it saves to the database, you could lose data. And finally, there's write around, which just bypasses the cache completely for writes. The choice here is really a tough trade-off. Do you need safety or do you need raw speed? Sooner or later, your cache is going to get full. You've run out of room. What do you kick out to make space for new stuff? This is your eviction policy. The most common one is LRU, or least recently used. It's simple. You just get rid of the thing you haven't touched in the longest time. Then there's LFU, least frequently used, which kicks out the least popular item even if you just looked at it. And then you get fancier strategies like SLRU, which try to be smarter, protecting really popular items from getting kicked out by a sudden burst of one-time requests.
All right, that was a lot of theory, I know. So let's make it real. Time for Section 5, caching in the wild. Let's see how the apps you literally use every single day put these exact strategies into practice.
Think about a big e-commerce site. They're definitely using CDNs for all those high-res product photos and a distributed cache for the product prices and descriptions. A social media app. They're probably using an LRU policy for your feed. What's recent matters most, but a super strict write-through for something like a like counter because that has to be accurate. And a streaming service? They are all in on CDNs for the actual video files, but might use a write-back policy for collecting anonymous viewing data in the background without slowing down your show.
And this really brings us to the most important lesson of all. There is no magic bullet here. There is no one-size-fits-all solution. As the source material says, no single cache strategy fits all workloads. Great system design is all about deeply understanding what your app needs and then picking the right combination of tools for that specific job.
So what this all comes down to is this. Caching isn't just a feature you turn on. It's a whole series of deliberate, thoughtful trade-offs. It forces you to ask the hard questions. What data absolutely must be fast? What data is okay if it's a few seconds out of date? And what's the real risk if something goes wrong? When you can answer those questions, you can design a system not just with a plan, but with a clear purpose. And that is how you build apps that feel absolutely effortlessly fast.